Okay, good evening everyone. It is a wonderful, warm, early spring night. Well, actually kind of mid-spring night here in Death Valley. We hit about 90 degrees today. We're going to be 95 tomorrow and Wednesday. So we've warmed up a little warmer than we should be, actually, about 10 degrees warmer than normal for this time of year, but it has just been some amazingly warm weather. So great night for astronomy here too. The warm-up periods tend to bring a lot of stable, clear air, and so we got a nice night for it here. A couple of minutes early, but might as well just start. So let's get rid of that. And now we need to bring our software. I never remember to do this. Make the software the right size so you guys can see it in your window. Then, okay, so tonight we've got kind of a Messier challenge list to do tonight, where Michael created a list where we could sort of do what we wanted, more or less, kind of focusing on Messier list objects, but sort of do what we wanted to do. And so I made a list of a few things. Let's see. I need to load this. No, click off. Okay, so I need to, I can't see the whole window. I need to import a list because I made our list for tonight. Observation list. Whoa, things jumping all over on me. Okay, and March 2025. And there is our list for tonight. And we're going to click the highlight all button and then close this. And then all of our objects. So we've got two objects right over in the area I'm at. I've used Sirius as my focusing star. So we got two objects right here in this southwestern sky to look at real quick. And we'll start off with those. So let's go to M41. The little beehive cluster. Now tonight I do have a little bit of a different field of view than normal. I've got the 6.3 reducer in, which means essentially we have a lot more magnification. So the field of view is a lot smaller. So we're not going to be able to see nearly as big a field of view as normal. But we're going to see things a lot more close up. And that's great for smaller objects. Which is mostly what we're going to do in this time of the year. Sorry, I'm kind of focusing on what I'm trying to get done here. During galaxy season, which is mostly some really small objects, I switch to the back of the scope, get the hyperstar off, and put the 6.3 reducer on, which basically zooms into a much smaller field of view, a much smaller slice of the sky, because galaxies they're small objects, and we like doing a lot of like seeing them up close. So I'm going to unstack that one because I think my light got in there, my red light. Basically I'm taking much smaller portions of the sky. So for these larger objects, like the open clusters like this one here, like M41, which is where we're going to start with, it's not going to be as obvious because we're kind of zoomed in a little bit much, but we'll still be able to see some nice stars. Well, the second sub did it again, so I'm not sure why this is brightening so much. Hey Mike, good evening. Welcome. Welcome, Daryl. I don't know how things are in East Texas, but it's been pretty warm here. But this is going to be M41, which is a little beehive cluster. In fact, while we're waiting for a few sub exposures to catch up on this. Let's go to, where is this, and the monthly challenge. I don't think actually he's got write-ups on a lot of this stuff. Yeah, I don't think he's got actually a whole bunch, so actually I don't think we're actually going to stay on that very much. No, come on. No. But M41 is a nice little open cluster that's in the very south, well, it's high up in the southern sky right now. It's in the constellation of Canis Major, the dog star, with the dog star Sirius, but this is Orion's hunting dog. So there's Orion right there, and Orion's hunting dog. M41 is right in the center of him, and it's this nice little open cluster that Charles Messier added as number 41 in his list of things. So got some nice multicolored stars in it. Got some yellows and some blues, and kind of a cool little thing. The open clusters would look better if I had a bigger field of view, because you could see it kind of a little bit better against the normal background stars. But in this case, we'll just get a close-up of the nice little colored stars there. Paul from Visalia. Welcome, Paul. Thanks for being here. Daryl says he imaged tonight for the first time in a week. Oh, good. Well, glad you got some nice weather, too. We're really warming up here. We were 90 today, 95 tomorrow, 95 on Wednesday, before the wind picks up and we cool off again. So we're in a bit of an early spring heat wave. But we're on the warming side of it, which means we get typically some nice air. And tonight is certainly good. Last night was also pretty well. But there's M41. We definitely got some nice little colored stars in there. So that's a cool thing. And we don't have to spend a whole lot of time on 41 because star clusters don't require a lot of time to see them because they're such bright objects. So let's go ahead and go right on to 93, which is our other one that's down here. M93. One of the things Michael said was pick a couple of Messier object open clusters. So I tried to stick to the most southern extreme stuff out of the list because I'm more south than most folks. So a little bit easier for me to see some of these things. For most people, these are pretty low in the trees. So, boink, there we are. And so here we have, this is 93, it's another nice little cluster there. This one is a little smaller, so we may be able to see it against the regular background stars a little bit easier. It's not quite as large and spread out as 41 was. I want to reduce this 15 seconds. We shouldn't need more than about 15 seconds for star clusters. Yeah. Another pretty little cluster. Is there a familiar name for this one? The butterfly. The butterfly, huh? Don't know that I'm seeing the butterfly itself, but start that over again. We got a little weird color on there. The butterfly. Well, we'll give this a few minutes and see what comes in. M93. The reason the Messier list, which is a list of 110 of the most spectacular objects in the sky, actually, to view. This time of year, those 110 objects can be viewed in one night. If you stay up all night, you can actually view all 110 objects in one night. And so it's called the Messier Marathon, and there are lots of amateur astronomers who like taking up on that challenge. So for this month's Cloudy Nights challenge, we decided to do it as a group. So everybody shoots a few, and we all come together and see if we can't complete the whole list, the whole group of us, in one challenge in 1 month, which doesn't sound like it should be too difficult. But obviously, when you're shooting all night long, some of the objects are only visible in the very early morning, in the pre-dawn hours. And that's tough for most of us, because most of us are evening astronomers, not nighttime or not morning astronomers. So basically our list is almost complete, except for the early morning stuff, which is basically in the summer Milky Way sky, as it's only rising, right before the sun. And so that's about all that's left on our list at this point. Anna, sorry, I'm new. How can I tell the diameter of the telescope being used? Thank you for asking, Anna. That's a really good question. And I'm going to show you right here, because this is something I should have started off with. Come on, you can do it. Slow computer. This here is the telescope that I'm using. Let's see, we're able to go there. Okay, so this is the telescope that I'm using. It's an 8-inch Schmidt-Cassegrain telescope that's sitting on my AM5 harmonic mount. It's on my spare no expense cinder block pier. So the camera, in this case, usually I have the Hyperstar on the front. You can see the Hyperstar is mounted on there, and the camera goes on the front. But tonight I'm on the back I have the camera on the back with the 6.3 reducer, which gives me a focal length of about 1200 millimeters with an 8-inch telescope. So a focal ratio of about 6 or so, for those who know what that means. But that is what I use. Is what I'm using tonight. Zoom in a little bit more on that, but that's it's an 8-inch telescope, Anna. Thank you for asking, because I should have started with that, and I forgot. Yeah, this is a nice little cluster. Anybody seeing the butterfly? I don't see the butterfly. This is supposedly the butterfly cluster, but it's a nice little cluster of stars. You're welcome, Anna. Any other questions, just shoot them to me. Happy to answer whatever I can. Alright, and I think now, well, this gets a couple more subs we'll take a look at. These are the only 2 objects that are actually on the western side of the sky. The rest of them are all going to be mostly galaxies on the other side. So we're going to do a meridian flip here, and we're going to go right to M81, which is next. And we will be doing 4 or 5 objects tonight that have not been done on our list yet. Where is Stellarium? Oh, it was already there, dum-dum. So our list tonight has got about 14 items. We're going to do more than 14, because we're going to do each one of the Leo triplet individually. Because again, I don't have the field of view to see more than 2 at a time. I might be able to get 65 and 6 together, but so we got about 14 objects anyway. And there are a few on here: 49, 61, 68, and 57 that have not been done yet by anybody. So hopefully tonight I'll get to check those 4 boxes on our list and bring it a little closer to completion. All the other things have been done, but they're just cool things to do, and they're part of his challenge, so we're going to do them. Alright, so there's the butterfly cluster. Fun little cluster. And we'll move on to the next thing. We'll flip over the meridian here and see our first galaxy. Where I'll go do M81. Nope, not PGC 280. We're going to do M81. There we go. Alright, let's flip around here. Okay, we have successfully flipped over the meridian. I don't know why you're going over there, but well, that's just weird. So this is going to say it's going to be a couple of degrees off, and 3 degrees off. And it's going to move it to some crazy place. And then I'll come back over here, and then re-slew, and it'll be right on. I don't know why it plays this game, but whatever. Yeah, see, so M81 and M82 are right together, but my field of view is so small at this focal length that, yeah, see, it's right there. My field of view is so small at this focal length that I can't get more than one at a time. I don't think we're going to do 82 tonight anyway. Other people do 82 much better than I do. It's called the Cigar Galaxy. And it's got some really nice color in it that I can never seem to get, including these relativistic jets that are coming out perpendicular to the plane of the disk itself. But I can never seem to get much color out of it for whatever reason. Other people just plain do it much better than I do. So I'll let them do that. But I love 81. 81 is one of my favorite galaxies. Oh yeah, Mike, there's Mike saying he did 81 and 82 last night. Along with some early morning Milky Way. Yep. Yeah, there's quite a few Messier objects in the summer Milky Way, so right now this time of year that's pre-dawn. So that's when you got to be up getting that stuff. And that's not me. There's that pretty M81. Okay, take some of the red out. And balance this histogram a bit better. And yeah, that will start to look nice. It's just this pretty swirly galaxy. I really love it. So we'll give this a few minutes. I'll probably spend about 15 minutes on each object before we move along. But so that's why I kind of picked objects that are worth the time. Some of the bigger galaxies with some interesting shape to them. How's our guiding doing? Our guiding is doing well. Alright, let's turn on our background music. So you guys are listening to something besides me. And we'll take a look at M82. This is one of our local galaxies. This is only about 12 or 14 billion light years away, which for us is a pretty darn local. That's a pretty darn local galaxy. In galactic terms, that's virtually next door. M81, 12 million, yeah. It's a grand design spiral galaxy, about 12 million light years away. It has a diameter of about 96,000 light years, so just a little bit smaller than the Milky Way. It's a popular target for amateur astronomers. Yeah. Discovered by Johann Euler Bode on December 31, which is why it's sometimes called Bode's Galaxy. Bode's Galaxy, Bode's Nebula, the Great Nebula, the Great Spiral. And you need to recenter back on the object and stay there. Thank you. It's a pretty one. Anyway, he discovered this in 1755. Is that right? Where did I see that? 1774. Then 5 years later, Pierre Marchand and Charles Messier re-identified it, and Charles put it in his catalog. So it is M81, the 81st object in his catalog. But it's a pretty one. I like it a lot. So I like shooting this one. Give us a little more stretch. It's got some color in it too. It's a nice sort of yellowish core, and then the bluish star formation happening out in the arms themselves. So we get a little bit of bluishness going on, even a slightly amount of red, the hydrogen areas too, but not real strong. Oh, thanks, Ronald. Really appreciate it. Yeah, it's been about a month since I was on last. Been a while, spring weather and all that. So it's nice to be back. We'll see how the weather continues this spring, but it's got really warm today. Got real warm today. So hopefully we won't have a scorching summer, but our winter was really mild. That was very pleasant to have a nice mild winter like that, but hopefully we can have a mild summer too. I would not mind one bit. But when you live in the land of extremes, you kind of sign up for it, so that's one of the prices I pay for living out here. But boy, the skies are nice and dark. So I like being out here. Now I seem to have people driving in my driveway, which may screw up my images. Not sure who this is. I guess I'll be right back. I need to go figure out who just drove up to my house. So anyway, I'll let you guys continue to enjoy M81, and I'll be right back. Okay, so I've had some folks actually show up here to see some of the things on my screen, so I may be muted a little more than planned, but I'll chat at you as much as I can. And we'll continue to continue to collect some light here on M81. Okay, so that's about 15 minutes on M81. And hi, Scott, I see your message there. Current background music. I'm not sure if that means you liked it or you don't like it or what. But anyway, we're going to go to the next object here. We've done M81. And let's see, so I think we're going to do 109 next, is the next one there, which is the vacuum cleaner galaxy. Yeah, so, alright. But I do love this galaxy, it's such a beautiful one. M81. Okay, so we're going to go next target here. And that eventually goes. Now I've clicked on this, and now I'll send the scope over to the new target. It's actually a stepper motor, but yes, you got the right idea. Okay, M89, the vacuum cleaner galaxy. Alright, let's plate solve on that to make sure we're on it right. And we're off by a little. So when we plate solve, the camera's taking an image, knows where it is, knows where it's supposed to be, and then moves the difference. It's called plate solving. We've been doing it for a long, long time, but now it's much more automated, where the computer just automatically repositions the scope to center your object in the sky. So, oh, you like? Okay, good, cool. Well, thanks for being here, Scott. Good to see you. I get you guys to tell me how your hike went the other day. I hope you found the petroglyphs. Good evening, George. Is it still snowing there? George is from Toronto. And he was snowing. I was sitting out here in my shirt, you know, my shorts, and his was snowing at his house, so. Because it's still winter up there in the North Country. Okay, so this is going to be the first sub on this, but it does take a minute. That's the downside of using a camera, is you gotta wait. You gotta wait for an exposure to come in. The shutter to snap. The virtual shutter to snap. There we go. There's that first one. And it's got a little friend here too, another galaxy right over here on the side. This one's got, it's a barred spiral galaxy that's got some neat swirls in it. So, as we, yeah, we'll just kind of leave it as is. I'll back it off a little bit. Just come on. There we are. Okay, so there's that. Negative snow, but oh, you're above freezing. Wow, so that means it's rain now? It was very dynamic weather, last 12 hours, rain, snow, etc. Yeah, you're probably right in that messy margin where it's one or the other, and sometimes both, and all freezes at night and it turns into an ice skating rink. Alright, so we'll let this continue to build here for a minute. Give this a little bit of time. This one's also kind of a cool looking one. I like this one. Alright, let's see what it is. I forget how. I think this is another fairly close one. 109. Oh, actually, it's about double the distance. This one's about 23 million light years. Well, central bar approximately 67 plus or minus 23 million. What? Actually, central bar approximately. No, this says it's about 70 million, I guess. Oh, which means it's gonna be a pretty big galaxy. House size, type size. Yeah, 175 light years across, so this one's significantly bigger than the Milky Way. So that's why, even at that distance, it still looks pretty big. So, about 120. Some people say 100, but I think currently the estimates are about 120. Yep. Yeah. So this is 70 million. This really was dinosaurs now when this light left this one. What's the bright arc on the bottom right corner? I don't know. I don't know. It's I don't know. It's a beauty mark. I'm not sure. Well, this is kind of... I'm not sure why they named it a vacuum cleaner. Maybe because it looks like the side of the rotor brush in the vacuum cleaner, but I don't know. It's called the vacuum cleaner galaxy for whatever reason. We'll give this a little bit. So turning on the annotation here, because I know we've got other galaxies in the view. And yeah, so see, this is another galaxy, and this is another galaxy, and this one, yep, was another galaxy. So there's a bunch of them in there. And in fact, if we back off, you can see there's several of them around. So there's a bunch of these. Yeah, these are all other galaxies that are much further away. No. And even with second exposures, you know, we can't. We're, you know, having. They're faint and they're small, even with the exposures we're taking. So, well, it's unlikely. It's pretty darn unlikely. You know, Carl Sagan, it's like he's given the numbers of stars that are out there. I mean, every galaxy that we see here, all this is all stars. You know, so there's billions, if not hundreds of billions of stars. Well, we think there's 400 billion stars in the Milky Way alone. All these galaxies have billions and billions of stars. So it's just a numbers game. Given the sheer amount of numbers, even if 1 in a million stars has a planet, and 1 in a million stars with planets has life, and still there's going to be millions of planets out there with life. Yeah, well, or maybe not. Maybe not. Maybe they're 2 million years ahead of us, but we won't know about it for 10 million years when they come knocking on our door. But who knows? watch and see what we're doing down here. And go, well, maybe not. Let's go to the next planet. Okay, well, while I was yakking with friends who stopped by here, there's a satellite that bombed through, and I missed it. Oh well, too late to get rid of it now. Won't worry about it. Do a couple more minutes on the vacuum cleaner. Too bad it went right through the object too. Drat. Anyway, we'll do the vacuum cleaner and then move on to the next thing here. What do we got next? Which is 106. Will be next. It is galaxy season. I don't remember what I was telling them versus what I was telling you, but this galaxy is about 70 million light years away, give or take. So, to see it this big and bright from 70 million light years away, it's pretty big. Kind of cool looking. Alright, but there's 15 minutes on that. With satellite streak right through it, but what are you going to do? You're busy yakking and you don't pay attention. That's what happens. Okay, now we'll go to 106. I don't think this has a familiar name, like Vacuum Cleaner Galaxy or Bodhi's Galaxy. Alright, we'll go to you. Do we get more than one? No, I don't think we do. Get more than one galaxy in this shot. My field of view is so small, it's pretty rare to get two things in the shot. In one shot tonight. With this setup. Alright, then we've got all these little blue circles of what we're doing tonight, including the Leo trio. This is one circle, but it's actually going to be, we're going to do 3 galaxies in there. And then 87 and 49, which is 49 and 61, which are two of the new items that we haven't, that no one else has gotten yet. 49, 61, and 68. Because 68 is so far south. Those are will be our contribution to the list tonight. Our contribution to the marathon list, because nobody has done them yet. So we'll be the first. Alright, about to get the first sub here on Messier object number 106. Oh yes, we do get a little companion in there. We do have just a little bit of a companion in there. Let's back this off a tiny bit. We're in Kasora, because they're quite a bit noisy. But yeah, it's got a companion galaxy. I don't think these are interactive. I don't think this one down here is colliding. I don't think they're gravitically engaged with each other, but we can look that up. But it's a cool looking one. It's got a couple of spiral arms and almost a 3D looking central structure. We'll leave its little companion in when we zoom in though. And let's take a look at M106's info in here. What we can see about that. And It's an intermediate spiral galaxy discovered by Pierre Marchand in 1781. It's 22 to 25 million light years away. It has a central supermassive black hole. NG4217 is a possible companion. So NGC 4217 is I bet you this is 4217. They're saying it's a possible companion. No, that's 4248. Huh. 4217 must be in the other direction. So there's 4242, 42. I don't see 4217. Well, you see 4217. Oh. Okay. Well, it's interesting that that doesn't even show up, but this one here does. 4248. Okay. Well, anyway. There we are. But 106 is a nice object. It's kind of a cool looking galaxy. Besides its two visible arms, it has two anomalous arms detectable using an X-ray telescope. Whoa. Two visible arms and two X-ray arms. M106 has a water vapor megamaser, the equivalent of a laser operating in microwave instead of visible light. And on a galactic scale, a megamaser is the equivalent of a laser but operating in microwave instead of visible light, and on a galactic scale. So it has one of these water vapor megamasers that is seen by the 22 gigahertz line, blah blah blah, dense warm molecular gas. Water masers are useful for observing nuclear accretion disks in active galaxies. The water masers in this galaxy enable the first case of a direct measurement of the distance to the galaxy, thereby providing an independent anchor for the cosmic distance ladder. It's one of the largest and brightest nearby galaxies, similar in size and luminosity to Andromeda. Supermassive black hole at the core has a mass of a very big number of solar masses. 3.9 times 10 to the 7th solar masses. 106 has also played an important role in calibrating the cosmic distance ladder. Blah 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 blah. Cool. Somebody needs some food. There we go. Good evening, Jason. Thanks for stopping in. We are looking at Messier item number 106, or M106, which is a cool spiral galaxy. And you can see as we're collecting more data, getting more subs in, the bright part is just the beginning. The outer part has got a lot more wispy outer stuff here. So there's a lot of stars in the fringes as well, not just the bright parts. In fact, I can probably stretch this a bit more now so you guys can see that a little better. Yeah, now it looks like you can probably see it a little better. Also see something here too. Is that a galaxy up there? I didn't see one when the... Oh, it is, yeah. From the UGC catalog. Yeah, it's a galaxy for sure, for sure. 4248 there. Well, good morning. Hey, Belgium, that's you. You're probably at the right. Well, let's see. 9:28 p.m. Yeah, it might be a little late for you to be doing the summer Milky Way there, but you can probably see some of the summer Milky Way there before sunrise right now. Sure if Belgium is 8 or 9 hours ahead of us here, but I'll put you somewhere around 5:30 or 6:30 a.m., which is probably still too light. Probably just barely too light to be able to see much. But you can definitely see now some of the outer stuff starting to come in on this. .28 a.m. Okay, there you go. Jason says, working on my setup since our last chat. Picked up 585. EQ Skywatcher. EQ 55. And an 80 ED SV503. Hoping to get it set up in the next couple of weeks. Yeah, well, I hope you do. You broadcast it so we can see what you do with it. That'd be fun. Uh-oh, we ignored a sub. Why did we ignore a sub? What happened here? Yep, we must have a little bit of wispy cloud up there somewhere that just caused the sub to get rejected. Let's see what this one does. Yeah, that one got rejected too. But it looks like it's coming up. We must have just a tiny little wispy cloud up there. I can't see anything with my eyes, but it could be just a really high thin cloud, just enough to trigger the brightness filter. Well, we'll see if it gets this one or rejects it. If it doesn't, I'll just drop the filter a little bit more. It just keeps ignoring them. Okay, then we'll just do 85 here. I don't see any cloud up there, but obviously there must be something. Oh, this keeps declining. What is up there? I don't see anything. Well, we may just have to move on from this object. Well, we got almost 10 minutes on it. But there must be some cloud up there somewhere that I can't see. Or just turn the filter off, and it'll get what it gets. It's nice having that filter on because it, yeah, see, it's still just really low. Oh well, we'll just leave it off for now. It'll be fine. We'll get a few more subs on this, and we'll move on to the next object. We'll probably move in on it a little bit. Give it a little bit of a zoom in. Start to see some of the cloudy texture in here. Looks like clouds, but it's all stars. And thanks for the thumbs up. You guys out there, appreciate the thumbs up on the video. Always nice to have an appreciating thumbs up. So thank you for those of you who gave me one. Almost getting cool enough now for me to go get a layer on. Maybe a jacket. Yeah, it is a pretty cool looking galaxy. Nice cloudy texture. Yeah, it just keeps getting worse and worse, and this is just, the brightness is just dropping off and dropping off and dropping off, like there are clouds or something moving in, and oh well, we're just going to have to live with it. The images might be a little fuzzy, but be better than nothing. What's after 106? What are we doing next? I guess we'll do Caldwell 32. I guess we could go up and do Leo. Yeah, we could do the Leo trio next. Oh, too far. You jumped too far. Yeah, these are all in a pretty good position. But if we're getting clouds, maybe I'll try moving away from this area a little bit. We'll see how things are around Leo. And do the Leo trio next. I hadn't planned on doing any Messier Marathon stuff. I'm not, while I am an astronomer of sorts, not too into being up all night long. So I hadn't planned on doing any of the Messier Marathon. So no, probably not. I didn't even know if they'd settled on a place to do it yet, because it seems to me David tried finding a couple places and they all fell through. So have they even found a place to do it at this year? Okay, that's 15 minutes. Let's see what happened. It's just sort of wavering down there. Okay, let's go to the Leo trio. 65. Now, I don't think I can get... Can I get 65 and 66 in one frame? I might be able to. I might be able to. Maybe this one? Yeah, let's see if I can do that. I'll get two of them in one. If I can do two of them in one, I think that'll... Let's see if I can do that. Let's try and get a twofer. With my narrow field of view, it's much more challenging than it is with my Hyperstar that has a nice big wide field of view. But let's see what we can do here. If I can get two in one, that'll be very cool. This is off by a degree, huh? That's a long way to be off. I don't know what you just did there, but there's one and there's the other. So I think we're good. Well, let's start it up and we'll see what we get. Lake Mead, okay, well, yeah, then I won't be going to that. Lake Mead is all the way on the other side of the world from where I am. I'm 80 miles west of Las Vegas, and Lake Mead is obviously quite east, so I won't be going out there. That's a long hike for me to go out there. The LVAS does a lot of stuff around They do stuff in the surrounding area around the city. They do star parties and things, which is cool, but I never join them because I have a hard time driving an hour closer to the light pollution to have a star party than just sitting in my yard. So it sort of causes a cognitive dissonance that I cannot resolve. So I tend to not go to many of those. But they do have them, and they're pretty cool. They're a lot of fun. Paul asks, what diameter scope do you have? I will show it to you. It is an 8-inch Schmidt-Cassegrain telescope that right now I'm using with the 6.3 reducer off the back, so I'm at about 1200 millimeters of focal length. But yeah, it's an 8-inch SCT. Hey, look at that, we got them both. Nice. So M65 and 66 in one shot. You're imaging UGC 6350. All right. UGC 6350. UGC 6350. Oh. Also called the Hamburger Galaxy. Alright, so you're right next door. We're going to do that one next. So, we're going to do all three of these bad boys. So I'm happy to have gotten two in one shot, so I'd have to do all three individually. Yes. Yeah, I just confirmed that, yes. AKA the Hamburger Galaxy. For some reason, Charles Messier put these two in his catalog, Messier 65 and 66 respectively, but he missed the hamburger. He never put the Hamburger Galaxy in it. So it has NGC numbers, but it does not have a Messier number. He even has an ARP number. But you know, it's the biggest and quite frankly prettiest galaxy of the whole three of the trio, and for some reason he neglected to put it in the his deal, in his catalog. Oh, that one's plugged in, but this one isn't. Okay. Try that. That's better. Okay. There are probably other galaxies in this picture too. Where are we here? Twink. Yeah, 66 and 65, and then all these other little galaxies sprinkled around. All right. Let's see what. These are a bit further away. These aren't one of the close ones. 66. Intermediate spiral, discovered by Charles Messier in 1780, who described it as a very long, very faint, very long and very faint. The galaxy is a member of the small group of galaxies that includes M65 and NGC 3628, known as the Leo triplet, or the M66 group. M65 and 66 are common objects for amateur astronomical observation, being separated by only 20 arc seconds. M66 has a morphological blah blah. It's a spiral shape with a weak bar feature and loosely wound arms. You can kind of see the bar. It's a weak bar, sort of right there. We can probably just zoom in a little bit. Yeah, you can see there's sort of a weak bar there, and a couple of nicely textured spiral arms. It's receding away from us with a heliocentric velocity of 700 kilometers a second. And it's about 31 million light years away. It's about 95,000 light years across. So with striking dust lanes and bright star clusters along sweeping spiral arms. So 95,000 light years across, so just a little bit smaller than the Milky Way. And 31 million light years away. Does have some pretty cool textured arms there. Okay, let's clean this up a little bit. That's probably about right. Oh. Thanks for stopping in, Dean. Yeah. Hit subscribe and every time I have one of these you'll be notified. Hey, Ollie. Good evening to you. You didn't get the alert on your phone. Well, there I am telling Dean to subscribe so he gets the alerts, and you didn't get an alert. Oh well. Well, you should, if YouTube is doing its job. Although what's kind of interesting, though, is that I subscribe to people. I subscribe to a number of channels. I never get notifications when any of them broadcast something or put up a new video. I never get any notifications to anyone I'm subscribed to. I have no idea why. It's I have no clue. For some reason I don't get notifications. YouTube sends me other emails. Like when I finish my broadcast, it sends me the email saying you did a broadcast, and I get emails from YouTube, but for some reason I never get any notification emails about anybody I'm subscribed to broadcasting or putting up a new video. I don't know why. So clearly the system's broken somewhere. Oh yeah, I totally am enjoying it. Actually, it's a little too warm. It was 90 today. It's going to be 95 tomorrow and Wednesday, which is that's actually a little too warm. I mean, I don't mind the warm, but it's a little early to be that warm right now. So, but the nights are gorgeous. I mean, this is just last night. I was on NSN. Dean was on watching my broadcast over there last night. So it was beautiful last night. It's beautiful again tonight. When we're in a warming trend, we tend to get really nice astronomy out here. When we're in a cooling trend, not so much. So last night, tonight are great. I think tomorrow, late afternoon, we get some clouds rolling in. So I don't think it's going to be so good for the next few days. I've got somebody coming in from out of town anyway. Somebody visiting me, so not going to be so good for a few days, but whenever we're warming up, the air we tend to have some good astronomy nights when we're in a warming trend. So this has been no exception. Had some nice weather. Oh yeah, well, turn off the alerts on your phone. It's gonna be silent, hopefully. Dean says, much too warm for me. Yes, well, yeah, but don't forget, you're what? You're up in Michigan, right? So 95 for you is a way different experience than 95 for us. 95 degrees, you can sit in the shade and it's completely comfortable. It's not bad at all. When the relative humidity is 10% or whatever. So up in your neck of the woods, 95 degrees usually comes with 75, 85% humidity. So that's misery. I'm actually from your latitude originally. I'm from New Hampshire, originally, and you know, an 85-degree day there is I will take 115 here over 85 there. It's just yuck. Do not like that humidity. Do not like it at all. So there's 66 coming in nicely. Let's go and not ignore our other little dude here. M65. The least interesting of the three, but still it's got some nice dust lanes going around in it. George, your pool hits 95, it'll be steaming. Yeah, you can see the dust lanes pretty well here. Not too bad. Can't wait to see where we're going to pull out a hamburger. Hamburger should be nice. You get little pockets of stuff in there. Is 65 a barred spiral? Let's see, it looks like it. No, it looks kind of mushy. I don't think it is a barred spiral. Let's see what they have to say here. 65, an intermediate spiral. No bar. 35 million light years away, so it's a little further away than 66. Discovered by Charles Messier in 1780. The galaxy is low in dust and gas, and therefore there is little star formation. In most wavelengths, it is quite uninteresting. I guess 65 is the boring one of the trio. There has been a suggestion that the three galaxies in the Leo trio interacted with each other about 800 million years ago. 65 may have a central bar. It's difficult to tell because the galaxy is seen from an oblique angle, a feature which is suggestive of tidal disruption. Yeah, it's kind of... it certainly doesn't look barish to me. But some nice dust lanes in it, though. But I think 66 is the better looking one. There's a lot more interesting stuff there. I'm already on it. Just about to get our 15th minute collected on this. So there's 66 and 65. These two guys. So now we're going to go pop over and do Mr. Hamburger. Alright. I shouldn't need to plate solve on that. Just a short little, very short slew. GC 3628. Hamburger Galaxy or Sarah's Galaxy. An unbarred spiral. Again, about 35 million light years away. Discovered by George's buddy, William Herschel, 1784. It has an approximately 300,000 light year long tidal tail. Its most conspicuous feature is the broad and obscuring band of dust located along the outer edge of its spiral arms, effectively transecting the galaxy to the view from Earth. Which we're going to see here in just a few seconds. Can SharpCap pull from a directory for stacking? Can it pull from a directory? I believe so, yes it can. Okay, this is not right. Where's the galaxy, man? This ain't right. How did you manage to... Alright, what happened here? Why are you... Now it says it's over a degree off? What are you doing? I'm still not seeing it. Okay, it says it's there. You lying to me again? Try this again. Pools say that it's first an hour. 1 a.m. bit chilly for me. Leo triplets are one of the most majestic things I've ever seen. Huh. Yeah, they are pretty cool. I think the hamburger actually is the best looking one of the bunch. So, 90s for tops, 2 weeks out of the summer. I hold up in the air conditioning. Yeah, it's 30 degrees right now. Yeah, you don't have to worry about AC. I think you and George are probably about the same latitude. So, he was getting snow last night. So yes, SharpCap I believe can pull from a directory for stacking. I think it can stack if you because there is an option in here to save the raw frames. Here you can choose to save raw frames differently, and then you can reprocess them later, either with SharpCap or something else. But yes, I believe it can stack from a folder, not just from a live camera feed. Here is the hamburger. Coolies. But that dark dust lane transecting the galaxy right down the middle, as the Wikipedia thing said. Okay, how are we doing on our list here. We got Caldwell. We still got these guys, 52 and 101, 51 and 101, but those can wait for a minute. I'm gonna get some of these guys. 68 we're gonna wait on for a minute. We got 87, 49, and 61. So these three down here, 49, 61, and 68, we have to get those. Those would be good for us to get. In fact, I might pop back up here and do 101, 51, just work our way down the line. As things continue to rise. But right now, it's the hamburger. I'm almost ready to go get a thin jacket on. It's almost started cooling off enough. Let's see, what do we got here? Still 64, so still pretty warm. So almost time to go get a jacket. Yeah, 64. It's getting downright cold here, George. Send me some of your heat. Paul says he's using Nina, so no stacking that I know of here. Really? I thought Nina, well, maybe Nina can't. You know, Nina is much more set up for AP. So, programmed overnight runs of data on an object for astrophotography. SharpCap is much more geared toward EAA, what we're doing. Much shorter exposures, shorter time spent on each object. For doing EAA, SharpCap is definitely the way to go. Nina has some nice tools for AP though, if that's what you're doing. Chet upstairs bedroom was 69, so yes, furnace on, bump. I wanted to ask you a question. So I picked up an E-mount adapter from my Sony to drop into the eyepiece of the telescope. I'm having trouble getting anything to show up on the camera. All I get are black pictures of nothing. Troubleshoot. An E-mount adapter for Sony. Drop into the eyepiece eyepiece of the telescope. I'm not sure. Does that mean like for your phone? For my Sony to drop into the eyepiece of the telescope. So I'm assuming that's a phone adapter. Thanks, George. Appreciate it. Hamburger's always nice. I like hamburgers. One of my more favoriters. We can zoom in a bit more on it too now. Wish it was oriented different, but oh well. Yeah, if Ollie, if you're asking about a phone adapter, I've never actually used one. But it's possible it's just off very slightly in one direction or another, and it's just not picking up. It's getting kidney beaning instead of seeing the actual object. So. How often do I stream? Usually once a month at least. Sometimes much more frequently. It depends on how much, what the weather's doing, what my work schedule's up to. Mostly the weather, though. And quite frankly, I broadcast more on NSN than I do on YouTube, simply because it's just easier to deal with. But I think I'm going to start broadcasting more on YouTube, actually. But yeah, so usually at least once a month, Dean. Sometimes more than that, though. But yeah, if you just look at my subscribe to my channel, you should get notification whenever I'm going to broadcast. I have an email list that I send out to as well, and for folks who send me their email address, there's no real great way to do that from a YouTube live stream, though. You don't want to put it in the chat, but yeah, I have an email list that I send out to, and if you subscribe to my channel, YouTube, and then ring the bell, click the little bell, you should get notified whenever I post a live stream I usually post it like 9 or so in the morning. At least 10 or 12 hours beforehand. I'll set it up and post it so that you should get a notification from YouTube if you're subscribed to my channel. So, you're telling me replace the lens on my camera so it can hook up to the telescope. My Sony A7. Oh, this is DSLR. Oh, I can't. Yeah, DSLR stuff. I can't help you with that. I have no clue. I've never owned a DSLR or tried to use them with a scope, so yeah, I'm not the man for you to help with that. I don't know. Yeah, I'm doing AP 5-minute subs all night long while I sleep. Yeah, stack and process on Cloud9. Yeah. Yep. And Nina's the way you want to go, no doubt. And you're in Michigan, furnace on is in our vocabulary a lot. Yeah, I love Hamburg. Hamburg is just really nice. It's one of my favorite ones. I like doing this one. Hey Curtis, good evening to you. Haven't seen you in a while. How's things? Yeah. Yeah, maybe Curtis can tell you, Ali. I'm not sure. When it comes to using DSLRs with scopes, yeah. I have friends in Las Vegas Club who do that, who use DSLRs on their scopes. They don't actually own that's not true. They own astronomy cameras too, but mostly they use DSLRs. But I don't know what adapters or magic is required to do that. For me, it's just straight astronomy cameras. Yeah, we're just one big old happy family going from one person's stream to the other. NSN, YouTube, whatever. Okay, the hamburger. You can even sneak a quick peek in, but really nice dust lanes in here. It's a cool galaxy with fuzzy stuff all the way on the outside. It's a cool looking galaxy, but it's time to move on because we got a lot of objects yet to do. So we're going to go to 101 next. All the way to the north end of the sky. Yeah, I really like the AM5. Mine has served me well, that's for sure. All right, you're there. Let's see if you can get the plate solving. AM5 works pretty well. I haven't been paying much attention to it. Yeah, we were at 0.5 there at the end of that one. Sometimes it can go a little wonky, but I've had good luck with it. It's worked really well for me. No, not at 1.9. I'm using the 6.3 reducer on the back of the scope. I took the Hyperstar off the front, using the 6.3 reducer on the back with sufficient spacing to bring it right down to about f6 even. So I'm at about just a little over 1200 millimeters of focal length. So my field of view right now is about 0.6 degrees wide by 0.4 tall. Very different from where I'm at with the Hyperstar, which gives me like a 2 degrees by 1.3, I think, or something, 1.5 degrees, something like that. When I go to the back of the scope, everything gets a lot smaller, but we can really zoom in. Yeah, reading. That whole reading thing, George, it's a concept. You may want to consider it. Might even help with your Wordle, you never know. There's that pinwheel. Yeah, we got kind of a nice shot of it. Alright. If I can turn the brightness filter back on. And we'll just sort of tone it down a little bit. But there's the pinwheel, M101. The Pinwheel Galaxy. Yeah, I agree, George. I might actually do some lunar work with this. Not really something I've done much of in the past. Most of my scopes have been light bucket newts and that kind of thing. And with the Hyperstar on this, it's an uber light bucket. But with the 6.3 reducer on the back of it, I get a lot of nice focal length. So we can do some. Maybe I'll do some moonwalking when the moon comes back here in a couple weeks. Could even ultimately try it at f10, the full 2,000 millimeters, and we'd really see some craters. Lunar road tour, huh? You think we can find roads up there? We got a big enough telescope? AstroToaster really does nicely with the images, the colors and saturation and gamma. I mean, it has a lot more adjustments than SharpCap does for color reproduction. Toaster does a really good job with that stuff, but it's so much more complicated than using SharpCap, you know, because you have to use DSS and then AstroToaster, and you're juggling 3 or 4 pieces of software to do what SharpCap does. So I don't ever go there, but from what I've seen of other people broadcasting with it, because, you know, Mark Bahu used to do that. He used to use DSS and Toaster. Yeah, it's got a lot of really nice adjustments and can do more with the colors and things than SharpCap can, but too many pieces of software to juggle for me, so I just stick with SharpCap. F10 or even F20. I don't think I have a... I know you can Barlow these things, but I don't know if you can stick just a regular Barlow in the back of them and that works, or you have to get a special vocal extender to be able to Barlow these, but it seemed to me you can Barlow them to 2 or 2.5x. So they can go out pretty far. I don't know. If I get bored when the moon is up, I may just decide to use 6.3 or just use it at F10 and see what we can do. I've only got one camera, the 183, which works great on the front, and then on the back like right now I've got it bin 2, and that works pretty well too, at about 1200 millimeters of focal length. With bin 2 I've got an image scale of about 0.8 right now, arc seconds per pixel, and that works. That's about nice. That's about perfect. But I don't know what it'll be at 2000 millimeters of focal length. I might have to do like bin 3 or something. I don't know if the 183 will work. Be a very small field of view, that's for sure. Alright, let's do some fix up on this, clean it up a little bit. To pop a little bit more. There we go, that's a little bit better. Get some nice color out of it now. Yeah, Curtis, you can give your talk to us. We can put you through your paces, and you can do your dress rehearsal on us. That would be kind of fun. I suppose, given that it's NSN and its big blue button, you could probably do whatever videos or slides you wanted to do as well. All right. M101, the Pinwheel Galaxy. Kind of a fun one. Okay, that's not going to get a lot more out of that one, so let's go ahead and do another one of my favorites, 51. Alright, let's plate solve onto it. Yep, we're right about pretty much there. So let's get going on it. I guess I should. How far away was the pinwheel? The Pinwheel Galaxy, that one was 21 million light years away. Discovered by Pierre Marchand in 1781. He communicated to Charles Messier, who verified its position and included it in his own catalog. So thus it was M101. This one is M51, the Whirlpool Galaxy, which is an interacting galaxy, which is really pretty. Not only because it's bright and easy to see, but because there's a nice color contrast between the two galaxies that are swapping material. This is a good one. This is a good one. Alright, we can take you a bit over that way. We're going to take you a bit out that way. Until you get a little bit more data. Interacting grand design spiral with a safer 2-active galactic nucleus. It was the first galaxy to be classified as a spiral. 31 million light years away and 77,000 light years in diameter. That is, of course, referring to the bigger of the two galaxies. It's such a nice one to image. So I guess I should probably say something about these guys. These are two interacting galaxies, and it's about 30 million light years or so away, these two guys, and they're sort of moving back and forth across each other. They're definitely interacting and swapping material back and forth, which is creating all kinds of tidal things going on in both galaxies. Lots of star formation because of the energy of that. So you're seeing lots of little pockets of stars being formed in here. These are not actual stars in there, but pockets of star formation that are occurring because these are gravitationally interacting. And so the little one is actually moving straight back away from us. So it's kind of moving toward us and then away from us. And they're kind of swapping material as they do that. I suppose at some point they'll just probably merge, I would think. The pronounced spiral structure of the whirlpool galaxy is believed to be the result of close interaction between it and its companion galaxy, NGC 5195, which may have passed through the main disk of M51 about 500 to 600 million years ago. In this proposed scenario, NGC 5195 came from behind M51 through the disk toward us, and then made another disk crossing as recently as 50 to 100 million years ago, until it is where we observe it to be now, slightly behind M51. So basically the small one is coming back and forth toward us and away from us and toward us and away from us. So it's come through the disk once already. It now passed through again, more recently going away from us. And so now it's sort of pushing away. And so it's further away from us. The little one is actually further away from us right now than the big one. And it keeps passing through the disk of the whirlpool and disturbing it. They're probably swapping lots of stars and creating all kinds of high energy events, like lots of star formations in both of the galaxies, most probably. Chandra X-ray Observatory thinks it may have even found a planet in this galaxy. I didn't even know they could do that. I thought they had a hard enough time discovering planets in our own galaxy. But definitely a pretty one to photograph. We're dropping subs again? Turn the stupid brightness filter off. Yep, there we go again. Same spot in the sky as before. Same invisible clouds. Well, I'll just turn the filter off. Don't need it anyway. Don't need it anyway, it's just fine. The way it is. One angle, trying to learn by Sony before I drop big money on an astronomy camera. That gravity trail, like a magnet of iron filings, is going to be out into the page, so to speak, this orbital pass. Sorry, George. I was on a different page and didn't see you chatting there. Yeah. Interesting thing about galactic collisions is that when they quote-unquote collide, they actually physically don't collide. You know, there's so much distance between all of the stars in a galaxy. I mean, they look like, you know, clouds of solid stuff. There's so many stars there. But they're so massive. Galaxies are so massive. There's so much distance between all of those stars that even when two galaxies quote-unquote collide, it's very rare for stars to actually bump into each other. Usually, it's just gravity. It's just gravity that pulls them apart. Not even usually, just it's gravity that pulls them apart and gives them weird shapes and, you know, does stuff like this with the streamers between them. And that's all gravity. Even when two galaxies literally pass through each other, it's not very common that any stars actually collide because there's just so much distance between everything. You know, if you step outside and look at the night sky and just imagine how much distance there is between all these things, that it's hard for another galaxy to, like when Andromeda eventually does get here and collide with us, it's very unlikely the Earth or the Sun or anything is going to get hit by something. Or at least so we believe in this here and now moment. Anyway, M51, very cool, very pretty. And I think we'll move on. We get a lot more objects. Okay, Caldwell 32. What is this? Oh, the Whale Galaxy. It's an ARP. The neat thing about the Whale is that it has a pup. The Whale and the pup. So we'll do that really quickly. Okay, Whale and pup. This one's actually another one of the very few we're doing this time that's not a Messier object. And there they are, the whale and the pup, as they're often called. We won't spend a lot of time on it, but it's kind of a neat pair of galaxies. Let's see, what is it? It is 4631. Let me see, 4631. Bard Spiral. Again, 30 million light years away. Discovered in 1787 by George's favorite buddy, William Herschel. Galaxy's slightly distorted wedge shape gives it the appearance of a herring or a whale, hence its nickname. Because it's seen edge on, professional astronomers observe this galaxy to better understand the gas and stars located outside the plane of the galaxy. It contains a central starburst, which is a region of intense star formation. The strong star formation is evident in the emission from ionized hydrogen and interstellar dust heated by the stars formed in the starburst. The most massive stars that form in star formation regions only burn hydrogen gas through fusion for a short period of time, after which they explode as supernovae. So many supernovae have exploded in the center of this galaxy. So many of them have exploded that they're blowing gas out of the plane of the galaxy. This super wind can be seen in X-rays and in the spectral line emission. The gas from the super wind has produced a giant diffuse corona of hot X-ray emitting gas around the whole galaxy. NGC 4631 has a nearby companion dwarf elliptical galaxy, which is NGC 4627, so that's the pup. That's the little one here. And together they were listed in the Atlas of Peculiar Galaxies, or ARP, as an example of a double galaxy or a galaxy pair. Oh, thanks for coming, Ollie. Good to see you again. Glad you got to be here. Okay, I think we'll take one more minute on the whale and pup here, and then we'll move on to the next. Some neat texture in this one too. Some of those dark lanes around the edges of the galaxy. Barnacles on the whale. Alright, that's 10. Let's see what's next here. Okay. Done those, done those, done those, done those. Okay. Next is 87. Virgo, the massive Virgo galaxy. Yeah, there's going to be a bunch of them in this view. Bunch of them. Okay. We are. He's up here. Mr. Virgo. This is a massive galaxy. I think they said there's like 1 trillion stars in this galaxy. But the interesting thing is that it also has a relativistic jet that sometimes I can see and sometimes I can't. I've never tried it with this scope before, so certainly nothing near this focal length, so we'll have to see if we can see the relativistic jet. But Virgo A is it's a boring galaxy to look at because it's just an elliptical. It's a blob in space. There's no spiral, there's no bar, there's no kind of interesting things to look at. But it's a massive galaxy. Lots of high energy and a relativistic jet. M87, generally abbreviated to M80, is a super giant elliptical galaxy in constellation Virgo that contains several trillion stars. One of the largest and most massive galaxies in the local universe. It has a large population of globular clusters, about 15,000 globular clusters, compared with the 150 to 200 orbiting the Milky Way. And a jet of energetic plasma. So we'll have to see if we can see that, see any of the jet. But there are several other galaxies around here, numerous others. But this here, it doesn't look like much. It looks like a big fuzzy star, but it is a super giant. It's several trillion stars, which is, you know, it's 10 times the size of the Milky Way. It's just massive. I think they estimate the Milky Way has about 400 billion stars. This one has several trillion stars. Charles Messier discovered it in 1781, cataloged it as a nebula. It's about 53 million light years from Earth, and is the second brightest galaxy within the northern Virgo cluster, having many satellite galaxies, several of which you can see here. Unlike a disc-shaped spiral, M87 has no distinctive dust lanes. Instead, it has an almost featureless ellipsoidal shape typical of most giant elliptical galaxies. Diminishing in luminosity with distance from the center, it forms around 1/6 of its mass. Forming around 1/6 of its mass, M87 stars have nearly spherical symmetrical distribution. The population density decreases with increasing distance from the core. It has an active supermassive black hole at its core, which forms the primary component of an active galactic nucleus. The black hole was imaged using the data collected in 2017 by the Event Horizon Telescope. It's a strong radio wave source. It has a diameter of 132,000 light years. With a it has an isophotal diameter of 132,000 light years with a diffuse galactic envelope that extends to a radius of about 500,000 light years. See the jet though. I'm not usually able to see it. Wait, I think that might be it right there. I think that might be it right there. Just need to back off on the stretch a bit. Yeah, that looks like it. Right there. Relativistic jet. I think that's it. A jet of energetic plasma that originates at the core of the galaxy and extends at least 5,000 light years, traveling at relativistic speed. It's one of the brightest radio sources in the sky and a popular target for both amateur and professional astronomers. Visibility properties. Whatever says any more about the jet. Luminosity. Its diameter is estimated at 132,000 light years, which is approximately 51% larger than that of the Milky Way. I thought the Milky Way was bigger than that. As an elliptical, the galaxy is spheroid rather than a flat disk. A accounting for the substantially larger mass of M87. Within a radius of 100,000 light years, the mass is many times the mass of the Sun, which is double the mass of the Milky Way galaxy. As with other galaxies, only a fraction of this mass is in the form of stars. The total mass of M87 may be 200 times that of the Milky Way. The extended stellar envelope of this galaxy, so in other words, the whole outer diameter, the whole fuzzy bit, is about 500,000 light years. The jet. The relativistic jet of matter emerging from the core extends at least 5,000 light years from the nucleus and consists of matter ejected from a supermassive black hole. That's interesting. Black holes are black because nothing can escape them, and yet this is matter ejected from the black hole. The jet is highly collimated, appearing constrained to an angle of 60 degrees of the core. It's powered by the accretion disk of the supermassive black hole. Pictures taken by the Hubble Space Telescope in 1999, the motion of M87's jet was measured at 4 to 6 times the speed of light. I didn't think anything could be faster than the speed of light. The phenomenon called superluminal motion is an illusion caused by the relativistic velocity of the jet. The time interval between any two light pulses emitted by the jet is, as registered by the observer, less than the actual interval due to the relativistic speed of the jet. This results in perceived faster than light speeds, though the jet itself has a velocity of only 80 to 85% the speed of light. Interesting. Yes, it is, Paul. This day and age, it is pretty amazing. Okay, well anyway, I think we've seen everything we're going to see from this guy. Yeah, that's the first time I've ever been able to see the jet that clearly, though. But that's definitely it. Or at least I'm calling it done. I think that's it. So, there's 87. Okay, moving on. Now we're going to get to some... Now we're going to get to some new stuff. So these next three we're going to do are... Actually, these next four, because the only four things we have left are the four that haven't been done yet. So 49, 61, 68, and then 57, which still hasn't even risen yet. So we may not actually be able to get that one. But these next three things are things that are not, no one else has done yet, except us. It is a galaxy, okay. M49 is a galaxy. And you can see it right there. Let's plate solve it to the middle. And then we will get going. It'll bring it right into the center. Boom, right there. Very good. And go. So this will be M49. Also a galaxy, and then 68 is a glob, and then 57 of course is the Ring Nebula, but you can see it's not quite risen yet, so we may have to wait till midnight to actually see it come up. Looks like another elliptical galaxy, which tend to be pretty boring galaxies, but this one doesn't have near the awesomeness of M87, but yeah, it's an elliptical 56 million light years away. Discovered by Charles Messier in 1777. It has about 6,000 globular clusters orbiting it. Huh. This is far more than the roughly 200 orbiting the Milky Way. But M87 had like 15,000, so, you know, all relative. On average, the globs of M49 are about 10 billion years old. So, we won't spend a lot of time on this because it's just like M87, it's just sort of a blob, a featureless blob of stars in space. And this one doesn't even have an interesting relativistic jet, so not much to see in this one. But we'll take a few minutes on it. Give it its due as the 49th object in Charles Messier's list of stuff to observe. His list of cool stuff to observe. Yeah, M57 is going to be rising in the northeast. I have a pretty low horizon in my northeast, but don't know. And 68 will be quick because it's just a glob. It's just a glob, so it's just a cluster of stars. It won't be, won't take much. But then 57 here, it's going to be rising in the northeast. Looks like it's a good, good little minute yet before it's going to rise. Probably be half an hour before I can see it anyway. Well, but this is M49. is this little blob over here? Is this another galaxy? What is that? Yeah, it is a galaxy. Yeah, looks like a barred spiral. It's a barred spiral of some kind. Interesting looking. Not sure what that's all about. But it's got definitely a circular shape here. I don't know. It looks more interesting than 49 does. Maybe I'll see what Stellarium might have the rise time of it. Ring nebula rise 23:35, so it should rise. It should rise in 20 minutes. 15 minutes, 20 minutes. And it'll probably be another 10 or 15 minutes anyway past that before it clears my horizon. Actually, Vega should be up. Okay, so I should be able to see Vega by now. Yeah, see, Vega should already be up. So I should be... Can I see Vega over there? I'll have to walk away for a minute. Be right back. Okay, yes, Vega is up. It's right next to a telephone pole, so this may be interesting. Let's see if I can get this thing. But Vega is up right now, and there's like a telephone pole right here. So, yeah, so I think probably in about, might be able to see Ring in about 20, probably right about midnight or so, maybe a bit before. I'll be able to see it. It's going to be close. It's going to be tight. But for now, we can do 61. The guider's complaining. It's just claiming that the scope is slewing. What are you talking about? I have no idea. I have no idea. But we're going to do 61, thank you. The swelling spiral galaxy. I think we can probably just go over there and get a start on it. Because we are not needing to get any more out of this. Obviously we're not going to get any more out of 49. Oh, the guy is interesting, but doesn't seem to be really developing into much, so... Anyway, we'll move along to our next target, which is going to be M61. You. Okay. Go. M61 right there. Alright. I shouldn't need to plate solve this. That was a very short slew. Oh, thanks, Paul. Appreciate you coming. Yeah, I'll see you next time. Thanks for being here, and good night, Dean. Yeah, I'm really glad that you were here, and subscribe to my channel, and then you'll be just be notified whenever in the future. But thanks for being here, guys. Much appreciated. Alright, M61 inbound. And then we've got 68 to do down here. Doink. 49, 61, 68, and then hopefully 57 will have risen by then. Oh yeah, look at that. Well, I didn't plate solve, and so it's not exactly near the middle, but it is a very cool looking galaxy. And yes, obviously it's got some friends here. We got galaxies all over the place in this image. But this is the one we're after right here, M61. Very cool looking galaxy, actually. Pretty bright for its size and distance. Let's see what we can see about Mr. 61 here. It's an intermediate barred spiral in Virgo, first discovered by Barnaba Oriani. May 5th, 1779, 6 days before Charles Messier discovered the same galaxy. Messier had observed it on the same night. Had observed it on the same night as Oriani, but had mistaken it for a comet. Its distance has been estimated to be 45.61 million light years from the Milky Way. It's a member of the M61 group. So 45 million light years away. M61 is one of the largest members of the Virgo cluster. It belongs to a smaller subgroup known as the S cloud. It is a weakly barred spiral with the suggestion of a ring structure and moderate to loosely wound spiral arms. It has an active galactic nucleus and is classified as a starburst galaxy containing a massive nuclear star cluster. It also has a central candidate supermassive black hole. $45 million light years away, but the Hubble image makes it look like much different than this, which is kind of interesting. Got my binoculars out trying to see if I can see the Vega's definitely up. I'm trying to see if I can also see Lyra. Top of Lyra yet. Come on. Oh, that's tough to grab. Meanwhile, this galaxy, unlike 49, which has nothing to see, this has got some nice detail in it. See if any part of Lyra has come up yet. Let's see, what will it look like when it does? Well, it's risen at this point. Just got to clear some very low mountains. In the meantime, we'll do the full 15-minute treatment on this. 61, because it deserves the time. There's a nice little spiral down there. It's like a barred spiral even. And then we got another interesting guy up here. That's an interesting one. Spiral guy there. There's 61, one with various companion galaxies around it. Doink and PGC. PGC. There's clearly another one here, but it's probably fainter than Mag 18, which is as far down as my catalog goes. Things are seeming a little fuzzy. I'm wondering if probably should refocus here. Only got a couple objects to go, but still. There's the 15th minute on M61. Yay. Alright, M61 is in the bag. So we're going to head down to 68. Let's go to Spica first, which will be a good star to use as a focusing star. We'll check our... Oh, why will you not select the dang star? Okay, let's go to Spica. Use it to focus on. Oh, there it is down there. Plate solve it up into the middle. Check focus, and then head to do 68. And hopefully 57 will be visible. Anyway, check focus right now. That's pretty good. Okay, so now let's keep going on to 68. Wink. This is going to be pointing right at my head, so I need to be careful I don't get my headlamp into the thingy. So we shouldn't need more than about 15 seconds on the exposure for it. There it is. M68. Nice little globby globby. Meanwhile, while this is taking a few minutes to collect some subs, I'm going to take the binoculars and see if I can see the rest of Lyra rising and see if M57 is visible yet. have just confirmed with the binoculars that I am not going to be able to see 57. Unfortunately, it's rising just a little bit too far south to clear the building that is it's basically rising right behind the corner of a building for me, and so I will not be able to, it won't be clear of the building for at least an hour. So not going to be able to get 57. I thought it was going to be, basically I have clear, I have a low horizon from north to about northeast or so. So I have clear, where am I? Okay, let's go over here. So there's M57. So I have clear horizon from about here to about here. And then there's a house. And it was because Vega rose here, I thought, oh, maybe I'd be able to see it. But it's not just rising, it's also headed south as it rolls around the Polaris. So it's now moved. I have a building right here. It's now moved. All of this has now moved behind the building. So unfortunately, it's not going to work out for me for doing 57 tonight. So I was able to get 60, 49, 61, and 68. So I got those three ticked off the list, but unfortunately 57 is not going to work. It's just a few degrees too far south, unfortunately. So that is going to about do it for my night. So thanks everyone for being here. Appreciate you all for watching, and I think that's going to just about wrap up my night. So again, a beautiful night here, and thank you, Michael, for a fun list and a fun challenge this month. And I will see you guys next time. Final look here at M68 globular cluster, way down on the southern sky. In the meantime, I am going to say good night. Thanks everybody for being here, and I'll see you